Right. Hello everyone, welcome. We'll wait a couple of minutes before we start, since I think I see people just coming in. Feel free to chat as you have already been doing in the chat bar, and also just feel free to vent, to complain, to share your experience, but also just be as kind and respectful as possible. We know that in every of these streams there are a lot of you guys with different levels of experience, and so one of the nice things about the Math Olympiad community, at least in theory, should be that everyone is pretty welcoming, and everybody also, if you can do a few questions, it's fun. If you can do a lot of questions, it's fun in a different way. So let's be as thoughtful as possible. Yeah, so the graph that is shown there, based on the timing, it should be pretty obvious. It could be a number of things, but this is the daily number of watch hours for this channel. As you can see, it also doubles up as a calendar almost for when the SMO occurs. So before we start, I just want to kind of say a word to future you if you are watching this in 2025. Right, for those of you who are in Sec 1, Year 1 or Grade 7 right now, you will possibly be looking at this again a year later. And I hope you're not looking at this 2 days before the 2025 SMO. That always happens, and the truth is that that's a bit too late. Right? If you're trying to do really well 2 days before the SMO, it's just definitely too late. So now that I've at least done a few of these cycles, it is very obvious that people only want to prepare for the SMO like a few days before. I understand exams and all, but for those of you in Sec 2/Year 2/Grade 8 and you'll be taking the SMO Senior next year, you definitely cannot prepare for the SMO Senior like this. The Junior this year is not so bad if it's the second time you're taking it, but for Open, you are in a lot of trouble. If you are trying to do this Senior and Open, you're in a lot of trouble if you try to do this a few days in advance. So I'll encourage those of you, especially if you're currently in, like I said, Sec 2/Year 2, to just join it tomorrow afternoon as well. This is not for the sake of growing my channel, this is just for your sake to get an idea of how Senior is like. If you join the stream and then you're like, oh my goodness, this is really hard, at least you know it's really hard. Okay, so we have got over 100 people in now. Usually I think there will be some of you who are watching this back on the recording as well, so because you are preparing for the SMO Open. So if you're taking the SMO Open tomorrow, all the best, and it most likely means for the few of you who are taking both Junior and Open, Junior is not the most difficult thing at all for you, so don't worry about this stream for now. If you're taking the SMO Open tomorrow, there is a high chance that this was not very hard. For everybody else, as you can see from the comment section, it is definitely variable difficulty through the paper, and also variable opinions about the difficulty of the paper. Now, before we go through the questions proper, I just want to comment something on difficulty, because this is also relevant if you're watching it now like after the SMO, and also if you're watching this like before the 2025 or some other SMO. Now, you realize that the cutoffs, I'm not going to say the scores right now, right? But we know that the cutoffs for gold depends on round 1 plus round 2, so that is sort of something else to talk about more when we have seen round 2. Right, so there's a round 2 cutoff, and then there's a silver cutoff, then bronze and honorable mention. usually the margins between the cutoffs is somewhere about 2, 2, and 2. That is usually the kind of range. We cannot really say exactly what the score cutoffs are going to be, simply because the SMO is the one who decides. The SMS is the one who decides. The SMS decides how many people they want in round 2 that year. So as I have shared with some of you, right, it says top 10% go into round 2. That is not true, because the number of participants is about 4,000 for junior, and there are about 100 qualifiers. I'm sure your brains are very tired right now, but you can count that that is not 10%. However, because that is in the official SMO rules, they can always revert it to 10%. The NUS lecture theatre is big enough. So if they suddenly decide that we really want to have 10%, they can fit 300 over people. Or they may not. So whenever we talk about cutoffs, there is always this caveat that it depends on what the SMO feels like doing. Now, another thing about the difficulty is that when we talk about hard papers, there is the fact that the round 2 cutoffs have almost always been at most 15. I'm not saying the cutoff is 15, okay? Someone's going to quote me and say, Mr. Wei Tan said that the cutoff for round 2 is 15. I did not say that. I'm saying that in recent times, the cutoff has been at most 15. Now, that just means that for any of these things, the hardest 10 questions don't matter too much. That's not the last 10 questions don't matter very much. The hardest 10 questions don't matter, except psychologically. Because if, let's say, the hardest 10 questions look really hard, it scares you, but it doesn't really affect the cutoffs. So please don't worry about the hardest 2 or 3 questions. Chances are that there are maybe 10 people who did it in all of Singapore if you're really talking about the hardest question. Right, so one final thing is that during the stream, because of the fact that many of you have watched the last few years, I'm not going through the usual set of slides about this, do not do that. I think you all have seen that already. Again, just be polite and respectful in your comments. If I say anything wrong, let me know. If my audio and my video cuts out at some point, just hang on a minute, because sometimes the Wi-Fi is a bit wonky. Other than that, we'll get going, and I will answer any questions in the chat that I think are convenient to answer, but not everything. So feel free to also help each other out if there's something that someone asked and I did not answer. Alright, so let's go, I guess. Okay, first question. Is it showing the question? Just want to make sure that So I'm using Microsoft Word this time, not the last time I used the Miro board as my sort of more compartmentalized into different slides. One of the shortcomings with it is just that it lags quite a bit. So if you've watched the past few streams, you know that sometimes it lags a little, and so my handwriting becomes pretty bad. So it's a bit more like elegant than Microsoft Word, but it lags a bit, and because of the streaming load on my not so advanced hardware, I think I'll just use Microsoft Word. So that's our plan for today. We can get started with the first question. And funnily enough, this is actually one of the things that is quite similar to one of my mock paper questions, where actually you get complex numbers in theory, but not in practice. In practice, you do not need to worry about complex numbers. In theory, x is a complex number. Now, by the way, some of these questions you're going to see here may look, and in fact I can recognize, they look like some of the questions I've set in my mock papers, whether on YouTube or if you're my students in our classes. Any resemblances are purely coincidental. I did not propose any questions for the SMO this year. So disclaimer here, none of these were proposed by me, but some of them look familiar, then good for you. The idea for question 1 is that indeed x is not a real number. You can try to solve it, you can try to factorize it, you can try to complete the square, it will not be a real number. So unless you are comfortable working with complex numbers, we have to look for something else. Something else that is not very long is to look at this and see that it is actually something that you've seen before. Something squared plus the first times the second item plus the second item squared is something that comes from our difference of cubes identity. If this is 0, then this is 0, and so x cubed is equal to 64. Now if you're wondering, but doesn't that mean that x is 4? No, it doesn't mean x is 4. The question did not say x is a real number. I'll acknowledge that something like this is a little bit unfortunate as question 1 of a SMO Junior, in the sense that it can be a little bit throwing you off. And question 2 is likewise a little bit unfortunate for the SMO Junior. One thing that is true of this paper is that it has a lot of ways to make computational errors everywhere. The second thing that's also true is that there seems to be a concerted effort to make it a little bit more scary looking than maybe some of the previous years. I feel that scary looking does in itself make it a little bit more difficult. And so if you're talking about cutoffs, yes, I agree that maybe it would be down by a point or two. Like, it's possible that a round 2 cutoff instead of a 15 could go down to a 14, a 13, I don't know, okay? But assuming whatever it is, somewhere about 13 or 14 is possible, then you would just look at 2 mark boundaries roughly down to your silver, bronze, and honorable mention. Right. Something like this is an example of looks very scary, also a bit confusing, but first of all, just note that you're comparing these 3 things. So don't work in the inequality. Pi to the a is just pi to the a. 1 over pi whole thing to the power of a is pi to the negative a, and 1 over pi is pi to the negative 1. Now we know that when we are taking exponents and the base is more than 1, pi is more than 1 obviously. Larger exponent means a larger value. So larger power gives a larger value, and so if a larger power gives a larger value, then that means that in this range, a is negative 0 point something, negative a is 0 point something, and minus 1 is minus 1. So this is the smallest, and this is the largest. So you go into your list of options over there, and this will give you your answer as option D. You can see from the multiple choice questions that the SMO this year, they are not at all really trying to make the questions in pure order of difficulty. This is generally true, but especially here, the advice that I often give, that I feel was especially a good idea this time, is that you want to go through the questions not in sequence. You want to start the paper by looking at all the problems and picking the questions that you find to be a bit more approachable to yourself. And so if you went in order, you may have been very frightened by the fact that why is it question 1 and 2 feel very difficult for me? And if you felt that way, that's a natural reaction. It's just that the way to avoid it would have been, don't start with question 1 and 2 if they look scary. Question 3. How many non-congruent triangles are there? So this is sort of like last year's round 1 question. If last year's round 1 question you knew how to do it properly, this year's one you still can do it properly, but with a little bit more work. If last year's one you guessed, then that would not work for this anymore. How many non-congruent triangles? So congruent triangles can be determined by the sides. Non-congruent just means different combinations of side lengths. They have integer lengths. The longest side has length 10 units, so 10 something and something. The something and something, I can just call them x and y. And the rule is your triangle inequality. So the triangle inequality tells you what kinds of x and y you can pick. And it just says that x plus y should be greater than 10 in order to be a triangle. This is not nearly as surprising as some of you who have not heard of the triangle inequality might feel that it is, because this is just the equivalent of walking in a straight line is definitely going to be shorter than walking in some other path. Sorry, I said x is longer than y, right? So the other way around. Going in this path surely is longer than this path. Take note also that it doesn't say that the triangles cannot be isosceles. It doesn't say the triangle cannot be equilateral. The longer side, there can be more than one with the same length. So your x and y, you just sort of list. You can start from 10, 10, 10, 9, all the way to 10, 1. If x is 9, don't write 9, 10, because that's the same as 10, 9. This will go down to 2, because x plus y is more than 10. So we just repeat this. And as I mentioned in my mock paper video as well, don't feel bad to list as long as you're not doing listing in a manner that is completely unsystematic and at random. If you know how you're listing by splitting into cases, these kinds of cases, just 10 plus 8 plus 6 plus 4 plus 2 gives you 30, is definitely not very bad. Question 4. I am at least 90% sure that I have this exact question somewhere in the notes that I designed a few years ago for like the SMO PS or the RIPMWC, and also I feel that it was in my notes for some SMO Junior. Like this feels almost like a question that is in any like angle lesson in an Olympiad class. So it's a good learning example. If like we're going to use this anyway again to highlight the point, is that the question gives you information about equal lengths, but it asks you about angles. So you translate all the angle information into lengths. And we're going to keep seeing this as we do a lot of the geometry questions today. Translating the information into angles, lengths, or areas. Move it towards the desired outcome. So AB equals to AC means these two are equal. BD equals to BF means these are equal. EA equals to EF means those are equal. And since all those three are equal, I can call them X. That's what I want. This angle here is the exterior angle of triangle BDF. And so therefore it is equal to 2x. So this is also 2x. And then now you can look at this triangle to get your answer x. Now, intuitively, if you're trying to guess, you can almost certainly eliminate angles like 33 degrees and 38 degrees because of the fact that the question doesn't give you any angles. There is no way that just by drawing some isosceles triangles, you can magically exactly create 33 degrees or 38 degrees. 36 degrees is nice because it's 1/5 of 180 degrees. Now, they gave these options because of the fact that some people will try to eyeball and use a protractor. I don't think you're allowed to use a protractor, but some of your teachers may not have prevented you from bringing in a protractor. Anyway, you can't use it because this is clearly not to scale. I screenshotted this off the paper, and therefore this is as to scale as the paper. AB does not look exactly equal to AC. So do not trust that the diagrams are to scale because the diagrams are not reliable, and we're going to get back to this theme somewhere later in the paper about how the diagrams can be deceptive, very deceptive. Okay. Last one for the multiple choice. Let x, y, z be real numbers such that the three denominators in this equation are not 0. So you're given three things that are equal. Find the value of 7x minus y over y plus 2z. A very useful idea for some of these questions, not necessary, but like one of the easiest ways to do these kinds of questions with a chain of equalities is to make them all equal to something. Those of you who know the sine rule from trigonometry, you don't need it for junior. I'm just saying, like, we have got a over sine a equals to b over sine b equals to c over sine c equals to what? Right? And that would be your extended sine rule. It's equal to 2r, 2 times of the circumradius. You always like to have what are they equal to, and in this case, I will just call them equal to n. Now that's because it allows me to just say 2 over x equals to n, means that x is equal to 2 over n. So y minus z is 4 over n. And z plus x equals to 5 over n. So from here you can get everything you want. X is already 2 over n, z will be 3 over n, and then y minus z is 4 over n, means y is 7 over n. You end with a fraction, so we don't even really need to put the over n. We know that the ratio of x to y to z is all that matters, so you can just put in actually 2, 3, and 7 as the values to substitute in. Okay, so the answer is option C. Is this a difficult multiple choice section? In terms of the amount of knowledge you need, not really. In terms of the apparent difficulty, maybe. Right? Especially for those of you who are in Sec 1, this will look a little bit more scary. Right? Last year they started with a lot of questions that are more comprehensible. Okay, so onward we go. We will carry on with the short answer questions. We probably will go up to question 10 before we take our first short break in between. Question 6. Now, question 6 is a problem that could conceivably have been asked also in a primary school Olympiad. Now, I'm going to mention and reference primary school Olympiad every now and then when talking about the SMO Junior. This is not meant to be derogatory to anyone who did not solve the question. I mentioned primary school Olympiads just to emphasize that for those of you who are newer to Olympiads and you're like, how come I didn't know this? Is it because my algebra is very bad? It's probably not your algebra, it's just that you did not have that many years of going through all these questions. So, no kidding, one of my suggestions is that if you're new to Olympiads, take the coming June holiday and actually like just try some of the primary school Olympiad questions. Like NMOS questions are quite easy to assess. Just try doing them. Obviously, you expect that you are faster as a secondary school student. Try them. see how you can do, and if you have got some questions that you can't do, at least you fill up some gaps. But you can use algebra to do those if you like. So that will change the dynamics a little. Okay, so anyway, back to this. This is sort of in the style of a primary school Olympiad question, because if this 2692 is divided by n, the remainder is 23, it means that n is a factor of 2692 minus 13, which is 2679. And likewise, for the second statement, it is also a factor of the other difference, 2964. Yeah, for those of you who are just joining in, a recurring theme of this SMO Junior this year is that there are a lot of computational considerations compared to some of the previous years. So wherever there are optimizations where you can calculate faster without a calculator, I will share them. So in this case, for example, you would like to find what is the highest common factor of these two, because n is a common factor. I mean, you want to find all the 2-digit common factors, but to find the 2-digit common factors, you just want to find the common factor. Now you can factorize them sort of by testing stuff, but that will take a while, right? And so some of you could not find the factors that quickly. One thing that you can use is what's known as the Euclidean algorithm. The Euclidean algorithm just says that when you are calculating the HCF, it is not going to change if you subtract one of them from the other one, or a multiple of one of them from the other one. Right? You don't lose any factors along the way. So when you subtract this, you're going to get 285. Now, another thing that you can do when calculating HCFs is that if there is some irrelevant factor, you can throw it out. For example, just divide this by 5, because 5 is clearly not a factor of the first one. And so now we're left with 57 and 2679. 57 is 19 times 3. I can see that 2679 is divisible by 3 using my divisibility test, so I will just do a quick division of 2679 divided by 19 to check whether it's divisible. So it turns out, yes, it is divisible by 19, and so that means that it is going to be possible either for n to be 57 or 19. Now, one thing that I would check is just to make sure that, yeah, the answer has to be less than 13. So it has to be more than 13, beg your pardon. So they could have been really nasty if they did something like, let's say, increase this by 7 and increase this by 7, and then now if you have this, then 19 would no longer work because the remainder should not be 20. There are lots of things that you have done that are careless mistakes. There are also a lot of things that you did not realize they could have done to you to induce careless mistakes. As a question setter, we kind of know some of the mistakes that can happen. Also get used to the kind of mistakes that you make. Recognize them, try to avoid them next time. It's personal to you. We know some that everyone makes, but you have the sort of weird mistake that you keep making, like forgetting 0 and 1, for example, for some questions. If you know that happens to you a lot, then just look out. Okay, question 7. This is easy for many of you, and the reason why it's easy is because you know what 512 is. If you don't know what 512 is at all, you should at least understand something that is true of any Olympiad, which is that there is a high chance that a big number is not a random number. A big number is there for a good reason. Of course, what I'm saying here is that this is actually 2 to the power of 9. How are we supposed to know that? We don't know specifically. You would try to factorize it, and then when you try to divide by 2 and 2 and 2 and 2 and 2, it will still keep happening until, if you list out the powers of 2, this is the 9th one. And so therefore you have got 2 to the x plus 2 to the 89 is 2 to the 9 to the 10, which is 2 to the 9t. And of course, 2 to the 9t is 2 times of 2 to the power of 89. And so your answer is just immediately x equals to 89. Many of you will ask then a question like, okay, how many factorials must I know? How many cubes must I know? How many squares must I know? How many powers of 2 must I know? I would say that you shouldn't be deliberately trying to memorize beyond just a few. I'm not going to define what a few is. You should not memorize beyond a few. However, if you do enough practice of Olympiad questions, whether it be the SMO, the AMCs, or even just like other contests from other countries that you may be taking, you'll get used to recognizing these kinds of common numbers, and then that will help a lot in your intuition. That's something that you can't learn from a class. That comes from your own practice and your own experience. Okay, number 8. I am fairly sure that I mentioned this as one of the patterns in my mock paper for this year, and I'm also, to be fair, certain that in the previous year's SMOs, this nested right-angled triangle theme is a recurring idea. Basically, triangle on the left, triangle on the right, and the entire triangle are all similar to each other. They're all similar to each other because they share the same 2 angles apart from the right angle. As a result, the 3:5 that is on AC to AB is basically not just about triangle ABC, but also about all the individual triangles, including the other 2. DB is 8 cm longer than CD. I can see that AD is going to kind of be the transition between them. CD to DA is 3:5, and then DA to DB is also 3:5. Again, your primary school ratio games, right? Just combine ratios times 3 on top, times 5 below, 9:15:25. The difference between them is supposed to be 8 cm. 25 minus 9 is 16, so you should just halve that into 4.5, 10.5, and 12.5, and BC will be the sum of those 2 things. Yes, sorry, I wrote the wrong letter. CD. Thank you. I'm very sure quite a lot of you saw right angles and then just thought Pythagoras. I have nothing against Mr. Pythagoras. He has made a great contribution to geometry, but also recognize that that's not the only thing you can do with right-angled triangles. At the SMO junior level, the most common thing that you will forget to do with right-angled triangles is going to be similar triangles. At the SMO senior level, the most common thing you will forget to do is trigonometry. So not just Pythagoras' theorem all the time. Question 9. Let n be a positive integer. A1, A2, A3 is this sequence of numbers defined as such. If A100 equals to 2024, find the value of n. Okay, n's appearing everywhere in the question. So step 1, especially if you're an SMO junior, is to just take a deep breath, because this looks scary. It's not scary if you were to just take things one by one. Now, take things one by one is actually the meaning of the question, by the way. This is a sequence. For those of you who do a bit of programming, you will know that this is like what we call a recursion. In math, we call it a recursive sequence or just a recurrence. And it means that A1, A2, A3 is just the first term, the second term, the third term of sequence A, and one of these depends on the previous one. So it depends on the previous one. In order to get to A100, it means that you would go to A1, A1 gives you A2, A2 gives you A3, and so on. Now, obviously, that doesn't mean we're going to list until A100, but we should certainly at least figure out what's A1, A2, A3, A4 before we panic. So that's literally what I mean by do it one by one. Start with A1. A1 is equal to n plus 3, n minus 1 plus 4. I just have to assume this is nice, otherwise if this is a big mess of square roots, I'm going to keep square rooting over and over again, so it must be nice. I expand it out. I see that it is n squared plus 2n plus 1, which is n plus 1 squared. So A1 is n plus 1. That's great. That does not mean that I now know the value of n, but it just means that it explains why it is nice. So now that A1 is n plus 1, we continue to get A2. This is how a recursive sequence works. It depends on the previous one. You put in k equals to 2. K plus 1 is 5. AK minus 1 is the previous one. We again trust that it should simplify. Which it does. How many of this should we do is essentially how many until you are fairly convinced of the pattern. We are not in an SMO round 2 based review right now, but for the SMO round 2, you do the same thing. In round 1, you just do and you convince yourself the pattern continues. In round 2, you do it yourself until you convince yourself that the pattern continues, and then you prove it by induction. So k equals to 3. Now, after some time, when you do this, apart from finding the pattern, you may also find the reason why. Now, the reason why this works so well is that this is actually, for example, n plus 5 plus 2, n plus 5 minus 2. Earlier on, this here was n plus 3 plus 2, n plus 3 minus 2. So the difference of squares is what actually allows you to have this very nice simplification each time. As such, this is what happens, right? It's just n plus 1, n plus 3, n plus 5, and so on. So A100 would be the 100th odd number plus n, which is n plus 199. So 1825. Not easy, but the difficulty is more in the framing of the question, right? That's what makes it a little bit weird. Okay, question 10. Smallest positive integer such that the sum of its digits is 2024. What is the sum of the digits of the number n plus 2? You want the smallest number. Priority number 1 is not small digits, but a small number of digits. So fewer digits means more 9s, gets you there faster. How many 9s? Divide by 9, and you're going to get 224 remainder 8. You'll see that this is not terribly important actually, but 224 remainder 8. It's just a lot of 9s and an 8. Yeah, I think the chat is already telling what is the thing not to do, right? Unfortunately, it does happen that we get half the logic and not the other half of the logic. So once you've decided on this, the smallest number, of course, comes from placing them in order. So it's 8 followed by a bunch of 9s is the smallest. There are 224 9s, but it does not matter to the value of n plus 2. N plus 2, you increase it by 1, it becomes 9 followed by a lot of zeros. You add another one more, and you get 9 followed by a lot of zeros and a 1. So the answer is 9 plus 1 equals to 10. Right, this takes us up to question 10, which are by no means the easiest 10 questions in the paper. However, of course, it is true that in these first 10 questions, so far, I think there haven't been too many so-called theorems or formulas that you would never have seen before. Alright, so let's take a 5-minute break in between now. Continue to feel free to chat, feel free to ask questions, and we'll be back in 5 minutes. So I see, of course, a lot of you are asking about cutoffs and well, general things about difficulty and cutoffs. As I said about difficulty at the start of this video, right, the difficulty of a paper, it depends on what you're aiming for. If you're, let's say, aiming to get into round 2 versus you're aiming to get something, like you're hoping you get an honorable mention or a bronze, versus you're in the top 20 or 30 and you're hoping to get almost everything, your experiences will differ. Now, I feel that this paper, for those of you who have a bit less experience in Olympiads, is very difficult looking, and the difficult looking is quite a significant problem, right? So there are many questions of the sort of like what I would consider to be medium difficulty questions and less easy questions. So if you have a lot of medium difficulty questions and not so many easy questions, it doesn't affect those of you who are, let's say, aiming for the top positions. But if you're a bit newer, it just means that there are so many things that can go wrong. Now, in terms of ideal difficulty, therefore, I think on average it is similar to like some of the slightly hard papers, but it is not like as hard as like those 2009, 2010, 2011 papers at that time, right? At the time when we took it, those ideas were new. Now, when you have seen these ideas here, some of these are new to you. In 2 years' time, you will not find this to be very difficult anymore. The other thing is, of course, that for computations in this paper, lots of things can go wrong. So many of you have, as you're seeing in the chat, are sharing all kinds of weird mishaps that have happened. All the weird mishaps will imply that there are going to be a lot of you who score lower than what you have the number of ideas for. So if you have got ideas for 15 questions, maybe you end up with 11, for example. If that happens to many people, it can cause the cutoff to drop. But it's very hard for me to gauge how difficult it is to do computations, right? Like a lot of 2-digit computations over time will just be like a huge torture, even though nobody can say that calculating 2-digit sums and differences and products is impossible. So use the comment section as sort of like a rough feel for the difficulty, and you can tell that it's not easy, right, if you want it in one word. Let's continue on. Now, question 11 is a problem that I feel like is actually somewhere in my lesson notes where I teach. So it is therefore going to be familiar to some of my students, whether it's familiar to you or not. However, one trick for any of these questions is always, in the SMO context, you can always assume a special case. If you did not know, for example, how to do this, you could always have assumed a special case like, let's say, A equals to 1 and B equals to 1/5. Because the answer is unique. So whenever there's a question that says, find the value of, and then you're like, but there are 100 different ways that this equation could be satisfied, use a special case. I'll explain the proper method, but I just want to say this, and I will bring this up whenever there is an appropriate instance to do so. So 1 over b minus 1 over a equals to 4. The way that you handle this is just to divide the top and bottom by a and b. Not by a and b, by a times b. Divide a by ab, you get 3 over b. You divide this, you get this. You divide b by ab, you get 1 over a. And then the same thing happens below. 3 over b minus 3 over a is 3 times 4. And 1 over b minus 1 over a is 4. So instantly this gives you 19. Earlier on I typoed the answer. Some of you, where you've seen the list of answers, yeah, I typoed it a bit. So sorry about that. So answer is indeed 19. Question 12. The 5-digit whole number 11ab6 is a perfect square. Find the value of a plus b. Now, question 12 question 13 and question 15 all fall into the class of problems that I will call bulldozable / brute forceable. You can bulldoze it over by just a ton of calculations, listing and bashing. Now if you are looking at a question, you should not do that immediately. Do not immediately resort to that. However, if you don't know how to do it, in the last 30 minutes, you could do these kinds by just trying out a lot of stuff. Now of course that's not the intended method, but practically speaking, I consider myself guilty party number 1 of using all kinds of lousy methods to solve questions. Lousy either as in like special case, as we just said, or lousy in the sense of like just do a lot of calculations. 1 or 2 more marks, the 2 more marks could be the gap between an honorable mention and a bronze and a silver in round 2, worth it. Now having said that, the way you're supposed to do this is quite efficient. You start by getting the number of digits. There are 5 digits, so it's close to 100 squared. Then you get it to the nearest 10. 110 squared is 12100, so this is in between. Now this is in between and the last digit is 6. So you look at which square numbers end in 6 and your possibilities are either 104 squared or 106 squared. So those are the only 2 things that you would actually be computing. And it will transpire that only the second one starts with 1, 1. So your answer is 2 plus 3 equals to 5. Question 13. Let n be 1 times 2 plus 2 times 3 plus 3 times 4 plus until 30 times 31. Now this is sort of the questions that first of all I just said brute forceable. That's not the intention, but if you really do brute force it, no one can really stop you from that. Now I'll show a couple of methods. Both of these are quite difficult to think of if you've not seen them before. The first method is that this thing can be a telescoping sum. Now, sort of like the partial fractions in our primary school Olympiads, you want to make things cancel. So first you sort of put one more thing and you write it as the difference. Now some of you are jumping up, albeit about 20 seconds delayed because of the stream delay. You're jumping up and saying, wait, no, this is not equal. Yes, I'm not finished, I left a blank. You see the 3 minus 0, 4 minus 1, 5 minus 2 are the common difference of 3, and so you can factor out 1/3 to cancel them off, and now it would be correct. So if you add all of this up, the sum will be 1/3 of 30 times 31 times 32, which you can numerically get to 9920. This is option number 1. Option number 2, as I think one of you suggested in the chat, would be okay as long as you know the formula for sum of squares. So if you know that the sum of squares, the first n squares add up to n plus 1, 2n plus 1 over 6. Every time when people ask me what's in the syllabus for the SMO, whether it be junior, senior, or open, I'll tell you in truth, I can tell you what are the things that you definitely need to know, but I cannot tell you everything that you need to know because there is no such thing. would not have said this is something you definitely need to know. But it's certainly something you can know, and hopefully after this you do know. Because if you know that you can add up the sum of squares from 1 squared to n squared, then your 1 times 2 is 1 squared plus 1, 2 times 3 is 2 squared plus 2, and so on. This would also have given you a way of summing it up. So we group it into a sum of squares. What is this? Okay, this one, 15 times 31 is 465. 5 times 31 times 61 is equal to 9455. So it gives you the same answer as it well should. There's also a third method that can involve the hockey stick identity. For the few of you that are taking SMO Junior and yet know some combi identities, you can use that. If you're like, what is the hockey stick identity? 2 methods is enough. Okay, worry about that another time. This is plenty enough. Question 14. Typical example of the 2 random equations. Find some random expression. But the 2 random equations in themselves are pretty ugly, but they are 2 similarly ugly equations. Now it's kind of like jigsaw puzzle pieces, right? Now each jigsaw puzzle piece is in itself not very nice, but they can click together nicely because they are similar. So because of the fact that these 2 equations are similar, by combining them in any normal way, you will get something that is quite symmetric and nice. So I do not want to do a substitution of, like, let's say let y equals to 4 minus x squared over square root 3 and put it here. It is not necessarily going to fail. It's just not very nice. Okay, so what I will do first, I notice that you have exactly the same coefficients. Everything is very nice and symmetric. So the first thing that I'm going to do is to just subtract them. Whichever order doesn't matter. So you get x squared minus y squared root 3y minus x equals to 0. Now you can factor this using a difference of squares, and that would mean that you have got x minus y and y minus x. So here's your factorization, and since x is not equal to y, that means that x minus y is non-zero. That gives you a nice piece of information number 1. Right? X plus y is square root 3. Now at this juncture, you could do a substitution in already of like x equals to root 3 minus y, y equals to root 3 minus x. It would then be true that x and y are roots of the same quadratic. However, I just want to carry on the same theme of symmetry that I've started by doing subtraction, so now I'm going to do addition. Now when I add them, I now get x squared plus y squared root 3x plus y equals to 8. This is 3, and so therefore x squared plus y squared equals to 5. Now this is going to be then a classic SMO Junior style question. And I say classic meaning that this exact formulation looks a bit scary with the square root 3, but if we now put this down, it would be something that is asked practically every year in one form or another. Right, so for the benefit of those of you who are less familiar with how to transition between these. We will just do it systematically anyway. The first thing to realize is that y over x squared plus x over y squared, you can combine into a common denominator of x squared y squared, and then this becomes y4 plus x4. So I just need to find x times y in order to get the denominator, and so I square x plus y, and I subtract this from this to give me 2xy is negative 2xy is minus 1. So the denominator is just 1 and therefore disappears. Now, as for x to the 4 plus y to the 4, that comes from x squared plus y squared squared minus 2x squared y squared, which is the thing in the middle that you don't want. This is 25, this is 2, and so your answer is 23. I'll consider this as relatively challenging for SMO Junior Algebra because of the initial step of adding and subtracting, but the second part of it will then be like a normal SMO Junior question difficulty. Question 15. Again, possible to list because the number of two-digit even numbers is not that many. And obviously when you look at it, the product of the two digits cannot be 0. So technically you can throw out all of those whose last digit is 0. You're only looking at the last digit being 2, 4, 6 or 8. I like to think about listing so that I don't have to list. Does that make sense? That means that I think about listing in a hypothetical sense, so that I do not actually need to list it out, because when thinking about listing it out, I already found out what is nice about it. So I can still split into cases, I just don't need to do as much work. Right, so I know that the last digit is 2, 4, 6 or 8. The last digit is 2, 4, 6 or 8, which would mean that I just check all of those. If n ends in 2, n ends in 4, n ends in 6, or n ends in 8. Now remember that n is not equal to the product of the two digits. N is a multiple of the product of the two digits. So the multiple of relation, this is 10a plus 2, 10a plus 4, 10a plus 6, 10a plus 8. Product of the digits is 2a, 4a, 6a, and 8a. I just need to find the a that satisfies it. Now in most of these cases, it is okay if you just now try all the values of a, but we can be a bit more efficient. So for the first one, 2a is already going to be a factor of 10a. So 2a divides 2 means that a equals to 1. So 12 is the value. For this one, if you take 4a, you can take away 2 of it, leaving 2a plus 4 is a multiple of 4a. Now basically what I'm doing here is just that if 4a divides 2a plus 4, it means that 4a must be smaller than 2a plus 4. You only really need to check a equals to 1 and 2. And only 2 works, so that's 24. This one, you again subtract off 6a from there. And once more, only a equals to 3 will work when these two are equal. Anything more and 6a is going to be bigger. And then this one is 8a divides 2a plus 8. Divides means it's a factor of. So I wrote it in this form because it's one less word. This doesn't work. 2a plus 8 is going to be smaller by the time a is 2 or more. So these are your only three possibilities and nothing else. Sum is equal to 72. Right. Question 16. We're back to geometry again after a brief break from geometry. And we will basically have special triangle and similar triangle. Quite frankly, that's like the only new thing at the SMO junior level. And so if you have got the fortune or misfortune, depending on perspective, of looking at this and the first thing that you think of is cyclic quadrilateral, that probably means that you took the SMO senior and just decided to show up here today. If the first thing that you think of is extending this thing out and H is the auto center, then you probably are taking the SMO open tomorrow and are just showing up here today. Neither of those are very necessary. You are doing an SMO junior problem. You're doing an SMO junior problem where the 30, 60, 90 triangle and the 45, 45, 90 triangle just gives you ratios of side lengths. And the two triangles that are related are AHE and BGH. Those two are similar triangles. You're always going to forget about similar triangles more than you're going to forget about something like Pythagoras. So just remind yourself, especially for SMO Junior. They are similar triangles, and so because they are similar triangles, the ratio of areas is just going to be the square of the ratio of the sides. I just need the ratio of the sides, and in order to get ratio of the sides, I should be looking at these two things because they are sides of the two nice triangles mentioned above. Okay. Quick exposition on this. I'm rotating it just because of the fact that it will help in my drawing. So this is EAB rotated. EAB, this is a 90, 45, 45 triangle. It's an isosceles right triangle. It means that the ratio of the sides is 1:1 is to square root 2. And so if this length here, I call it x, this is going to be x over square root 2. Now the other one, AGB, the 30, 60, 90 triangle. This is the only other combination of angles that they can ask you for the SMO Junior, and you're expected to know what the side length ratios are. Because this is half of an equilateral triangle, and so it is 1:2, and then by Pythagoras this is square root 3. So if you know your sine 30, 60 degrees, 45 degrees, of course you can get that as well. But those also come from the fact that it's half of a square and half of an equilateral triangle. So GB is half of AB. That's enough because it means that the ratio of AE to GB is 1/√2 is to 1/2, which if I multiply by 2 is √2 is to 1. Therefore, the ratio of the triangle areas is 2:1. And your answer is half of 50 equals to 25. Now you could actually do a lot of algebra to find out what are the values of GH, HE, AH, BH, all those can be found. They are just not relevant here. So always remember to read the question statement. The thing that they ask you for should be the nicest thing to find in the question, not the easiest thing. but the nicest thing to ask to find a question. Certain things are just not very nice to find. They're not asking you to find it. Don't go and find it. Right. We will go to the bottom of the actual question paper, question 18, this page, which means 2 more questions before we take our second short intermission. Okay. Question 17. Find the smallest positive integer such that square root n minus square root n minus 1 is less than 1 over 99. I feel that for those in my class, I've asked you a question like this about 4 times, but unfortunately all the 4 times I chose the denominator to be even. So if this is odd, I hope you are not too shocked by it. It's just annoying, but it's fine. Okay, now what do you want to do here? Now the idea for a question like this, to me, in terms of not having a calculator with you, the idea for a question like this is to try your best to make it into an estimation problem with an easy thing to estimate. When it comes to square roots, the difference of square roots is very hard to estimate. The sum of square roots is easier to estimate. So I'm going to reciprocal both sides to that end. Remember that when you take reciprocals of both sides, the inequality sign will flip. And then this one, I will use my conjugate to clear the denominator. The denominator becomes n minus 1, which is 1, and so that is gone. So you get something here which is much nicer. Root n plus root n minus 1 is greater than 99. Why is this nicer? It's nicer because it means that I want the smallest n such that it exceeds 99. It means that the bigger square root needs to be at least 99 over 2. And so n needs to be at least 99 over 2 squared. One more calculation to do. Okay, so n is going to be at least 2451. Now this does not guarantee it works, despite the fact that some of you would have just put down 2451. This turns out to be the correct answer, but technically speaking, it is not 100% certain. So if you put in n equals to 2451, how are we supposed to know whether this is actually more than 99 or not? The easiest way here is to just square both sides. I'm not going to actually multiply as many things as you might be concerned about, don't worry. We've already squared 99 over there. So if I subtract this over on the other side, and then divide by 2, we get something that is clearly true. The square root of 2451 times 2450 is more than 2450, right? This is correct. So this is confirmation that 2451 does work. Although I would err on the side of do not need confirmation during the SMO, unless you have time and you've done everything you can. One more before we go to break. Question 18. Let A, B, C be real numbers such that A plus B plus C equals to 8 and AB plus BC plus CA equals to 0. Find the maximum value of 3A plus B. I'm fairly certain that I just talked about, again, a question very similar to this at some point. Now, I keep saying about similar questions. During your own practice, during your own learning, it is a good thing to do unfamiliar questions because you're expanding the set of things that you understand and find familiar. During the SMO, you should just hope that everything is really boring and familiar. Because if they're all boring and familiar, that's good news during the competition. Maybe a bit boring if, let's say, you only do all the familiar questions, but if you've done enough preparation, just doing the familiar questions will help you to do quite well. Familiar questions are not easy. Like, this is not easy unless you have seen the idea before somewhere or someone has told you. Now, intuition, first of all, is that the maximum value of 3a plus b happens when a plus b is big. So you want c to be small. It's quite hard to say a plus b is big, so I don't really know how to make a and b big at the same time. But I can think about just c is small. C is small, a plus b, by definition, okay, I'll write that below. By definition, a plus b is 8 minus c. So if c is small, this is big. Small could be negative as well. Now, next question I'll ask is that why can't I make c really small? Like, why can't c be, let's say, a negative 100,000? Now, clearly, if c is negative 100,000, something must go wrong. Otherwise, the answer will not fit in the SMO sheet. But why cannot it happen? It cannot happen because if I look at the second equation, I can factor out the c from here and substitute in a plus b into here as well. And so I get ab equals to c squared minus 8c. So a plus b is 8 minus c, ab is c squared minus 8c. From these two down here, I'm able to get a relationship between a plus b and ab. The relationship between a plus b and ab can be via AMGM. Since you are hoping for c to be negative, then both of these will be positive. So it can be via AMGM, but I'm going to just go with the Vieta's approach, which is to say that a, b are roots of the equation x squared minus 8 minus c, x plus c squared minus 8c equals to 0. And for a and b to exist as real numbers, it means that the discriminant is greater than or equals to 0. Now, I said in the previous video that discriminant is not technically in the SMO junior syllabus. Clearly, I'm not being very accurate there, right? The discriminant is something that is definitely in senior, but all the things like Vieta's discriminant quadratic formula, all these sorts of things are sort of a grey area. Does junior test it or not test it? You better know as many of those as you can for the purpose of doing algebra. Okay, so discriminant. This squared minus 4 times 1 times this should be greater than or equals to 0, and then I expect. I personally don't like to have a negative at the front, just personal dislike, so I always negate it and flip the sign first before I factorize. So factorize. In order for this factorization to be negative, it means that c is between the two roots of this, and so to make it as small as possible would be negative 8 over 3. Comes back here. When you see the 3 on the outside, right, there is maybe a 30% chance the SMO was just trolling you, but there is a 70% chance that it means that a plus b actually was something over 3. So seeing something over 3 should give you a little bit of confidence you're in the right direction. Alright, so we'll take a 5-minute break. Remember, for those of you who need to like have an early dinner or something, or your brain just hurts, this will be up here. I hope no one taking this as a lesson actually copying notes, right? You do not need to copy notes. This is a YouTube video. If you are watching this back like on delay, or if you missed the first part, you can always watch it back. It will remain up forever, just like the previous years as well. Okay, so we'll take 5 minutes, and then when we come back, we will look at the final 7 questions of this paper. Before we continue, just a word about round 2. Round 2 is 3 hours and 5 questions. Round 2 is full solutions. You basically get a couple of marks at most if you just have a correct answer. Round 2 is pretty hard, to put it mildly. If you think you have got a decent chance at getting into round 2 after today's paper, of course we haven't gone through the last few, but if you think you have a decent chance of getting into round 2, please, as soon as possible, do start looking at some of the past year round 2 questions. But if you are like borderline, just do not be discouraged by the fact that like there is a high chance almost all of them will look impossibly hard. It is generally true, if not always, but generally true that for the SMO Junior, if you can get 1 out of 5 questions fully correct in round 2, you have quite a good chance of getting a gold. Right? Meaning that if let's say you got just the cutoff for round 1 and you got 10 marks in round 2, you already have a decent chance, and if you get more than 10 marks in round 2, you're almost guaranteed to get a gold. If you get 2 questions correct in full, you have a pretty good chance at being in the top 30. If you have got 2 questions, it's not guaranteed. It depends on the difficulty of the year. So I would encourage, and even if you think I'm not going to get into round 2 this year, still take a look anyway. The reason why, like let's say for me, I do teach round 2 of SMO Junior to some of students who did not necessarily qualify for round 2 is that I think it's fun. I think it actually helps you to think in a different way, because for many of these questions, you need to first be able to solve them in 30 minutes before you can solve them in 10 minutes. And that's true for many of the last few questions. You need to kind of discover certain things. And if you can solve them in 30 minutes, eventually you'll get fast enough to solve this in 10 minutes. But if you can't solve it at all, then that is the initial thing to resolve, right? So get used to working on questions slowly is what I want to share. Okay, so question 19, we're back. In the table below, every row and column is an infinite arithmetic progression. How many times does 2025 appear in the table? What I would like to do here is to just describe the pattern more precisely, because they've just said it is an arithmetic progression, so it's a number sequence with a common difference. But what exactly does it entail? I mean, I can see the odd numbers on the outer columns, but that's basically all I can see. So what I'm going to do is this, right? I'm going to just put the row numbers and column numbers. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I'm going to try to describe the pattern. So in row n, the first term, these are odd numbers, is 2n minus 1. The difference is plus 2 in the first row, plus 3 in the second row, plus 4, so it's just n plus 1. Which means that row n, column m, you start at 2n minus 1, and then you will add n plus 1, m minus 1 times. Okay, so this is not the nicest way to do it, because I think it should be symmetric, right? No reason why it should look so asymmetric. So I'm going to grab 2 more copies of n plus 1, which is 2n plus 2, and that will leave me with negative 3 on the outside. So this is my statement, which some of you will have found by pattern. It's quite a hard pattern to describe fully, but this is what I can find by pattern. So what some of you may have found by pattern, this is what I would find systematically. So this thing equates to 2025. Now move the 3 over and you end up with n plus 1, m plus 1 equals to 2028. And you want to know how many times it appears, means I want to know how many m and n work, which means that I want to count the number of factors of 2028, because that will give me the number of combinations of m and n. To count the number of factors, I need to factorize this first. So 2028 is divisible by 4 but not 8, divisible by 3 but not 9, and then you'll be left with 13 squared. Now, some of you asked me before the SMO about year numbers. Do we need to memorize year numbers? I'm sure that even if you memorize a lot of year numbers, 2028 is quite far away, right? So just do it in the actual SMO. If it's this kind of number, not too bad. Number of factors, you compute it by taking the exponents plus 1 and multiplying them together. So there are 18 factors. Pause and think about a couple of things every time when you have this sort of big, clever counting argument. Worry about the small details next. Small details are as follows. Number 1, will it matter if I swap m and n? Am I overcounting? The answer is no. Because if let's say I've got row m column n and row n column n, that is two different places. So counting it in both directions is good. Second thing to check, are there any weird individual cases that I need to throw out? And this time the answer is yes. The answer is yes, because 1 times 20, 28 would have given you n equals to 0, and there is no row 0. Right? Likewise, the opposite direction. So everything else is fine except for the pair of 1 times 20, 28 and vice versa. So the actual answer is not 18, it is 16. Okay, question 20. Remember, if you were here about an hour ago, the first time where I was slightly ranting about diagrams was question 4. This is rant about geometry diagrams number 2. Do not trust the diagram, because if you looked at the diagram, you may get tricked. You see, the thing about the diagrams is that they are not all bad. It's just that they give you good ones when they have no use, right? Like if let's say you look at question 16, the diagram is not bad, but not very useful. It's actually quite close to being 30, 60, 90 and 90, 45, 45. Some of you have a protractor and you have the question paper, take it, it's quite accurate. Doesn't help because of the way they ask the question. This one, if it was to scale, it would be really useful, because you could just just chop it up into this and say, okay, maybe this equals to this, but then is it or is it not? I know that it's not perfectly to scale because it tells me that DC is 3 EG, and I'm looking at it and it looks more like DC is like twice of EG, so that doesn't look very accurate. So do not trust the diagram when it is clear that at least one of the pieces of information is clearly not accurately drawn. You have two options then: draw your own diagram or use theirs. I would generally say use their diagram, because I don't think you can draw better than their diagram most of the time. So just don't get tricked by the scale. Now, on the question itself, we are told that DC is 3 EG. So this is the third instance where I kind of look at the two right angle isosceles triangles that they mentioned. Obviously, by definition, that means that they are isosceles, and therefore they are similar. But it also just means that they are similar with that ratio 1:3. I can just label all of this using 1 and 3. Now, I'm not saying the lengths are 1 and 3, it's just kind of like 1:3 in terms of ratio. And then what do I do? The idea is that I need to know how small are the small triangles, which is like this BEF, in order to get the ratio of the big triangle. So if I call this length here x, the small similar triangles that I can use are going to be BEF and BDG in this pyramid pattern that I have shared before. Right? Remember this pyramid pattern, and this would give you the value of x. X is to 1 equals to x plus 1 is to 3. You cross multiply, you end up with x equals to 1/2. Now, if this is half to 1, it means that the small triangle BEF is in the ratio half to 1, which is 1 is to 2 for the two legs of the right angled triangle. And therefore, for the big triangle, this whole thing is also similar to those other two. It's also in a 1 is to 2 ratio. BC is 9/2, so AC would be 9. Again, all of this is ratio. I just don't want to keep on writing half unit, 1 unit, 3 unit, 9 units, so they are all units in a sense. And that's good enough, because now if I compare ADC to DGC, they have the same height, same base. Is it base or height? Same height. GC is the height, but 3 times of the base. Right, so this is 3 units, this is 9 units. Therefore, the area is just 3. See, one of the troublesome things about the SMO is sometimes as follows. They just keep on repeating the same idea in the same paper. Right, so for example, they keep on repeating similar triangles over and over again. So it's very painful. On the flip side, some of you will find it easy because you have practiced a lot of questions that allow you to recognize similar triangles. So all of the similar triangle questions become doable. This does happen a lot. So you don't want to try to guess topics based on the last 2 or 3 years. Otherwise, if something like that happens that is different from what you expected, you get very disappointed. So the past year questions are useful resources. My mock papers, I would like to think, are useful resources. But the past year questions are not representative, and I cannot guess what will be tested. Now, question 21. This is a question that I've actually used the idea of it in one of my SMO Open mock papers, and this is a question that originally is from the AIME some years ago. This is a question where the idea is pretty nice, but not so simple. Now, you start by recognizing that a plus b plus c plus d is 2024, a squared minus b squared plus c squared minus d squared is 2024. In isolation, both of those equations are not very surprising. But again, they are the same value. That's important and a bit surprising. A tip for these kinds of counting number of solutions is that if you can't seem to count how many there are, that's probably because you don't even know how to find 1. Now, I'm not saying the answer is 0. I'm saying that try to find 1 in order to discover what is so difficult about this. If you try to find 1, what will happen is that, for instance, if you tried something like A is 600 and B is 500, you will realize that this is huge. 600 squared minus 500 squared is 110,000. That is huge. And in fact, square numbers increase very fast. So that motivates the fact that A and B have to be very close together, C and D have to be very close together to prevent this from exploding. So how do I prevent this from exploding? I say A and B must be close. How close? Very, very close. They must be 1, because this here, A minus B is already at least 1. C minus D is already at least 1. And so this is 1 or more of A plus B plus 1 or more of C plus D is 2024. But 1 of A plus B and 1 of C plus D is already 2024. And so the only way that can happen is that both of these are 1. That is very good news, because well, it means, among other things, that I can ignore this equation, because if a minus b and c minus d are 1, it's now saying the same thing as the first equation. I can just substitute in a equals to b plus 1 and c equals to d plus 1 and count that. b plus d is 1, 0, 1, 1. And now it's just positive integers. Remember, b is more than d, and so you can write down b can be 1, 0, 1, 0, d is 1, 1, 0, 0, 9, d is 2, and so on until the middle. 1, 0, 1, 1 divided by 2 is 505.5, so the closest they can be is 506 and 505. Yes? No. Not at all. What? Why not? I just said a moment ago, right? Remember when you list out a whole lot of things, check the ordering. So in this case, B has to be bigger than D. Also check if there are any weird cases that don't work. If B is 506 and D is 505, what is C? So not this guy. But all the other guys are okay. So 504 solutions. Whatever B and D are, A and C are just 1 more than them. But they need to not overlap. Okay. Question 22. Some of you who saw the review for last year, 2023, have seen the quadratic graph. You've seen the quadratic graph. This case, you do not really need to draw a quadratic graph, even though if you can, good for you, it doesn't help a lot. You just need to know 2 things. One, you need to understand what a graph is. A graph is just a bunch of points that satisfy the equation. The second is that A lies in the first quadrant. You just need to know that the first quadrant is here, where x and y are positive. That's all that first quadrant means. Okay, so I will draw a graph just as a visual aid. I draw a graph as a visual aid, but you do not need to draw the graph. If you drew the graph, you would realize that it would look something like this, where B actually has negative coordinates. If you did not draw the graph, it's okay, as you will see, right? It does not give a problem. Now what I'm going to do is that I'll just call the point A xy itself first, and I'll pretend that I did not have the graph and I did not know that B is in the negative side, and I'll show you what will potentially go wrong. Right, so I let A equals to xy. So that means that literally y equals to x squared plus 5x minus 8 is true. Now if OAB are collinear, O is the origin, and OB is twice of OA, it means that you thought that B was here. That means that you thought that B's coordinates are just twice of A's coordinates. So if you thought that B is actually going to be 2x, 2y, then the 2x and 2y now satisfy this equation. So it will be 2y equals to 2x squared plus 5 times 2x minus 8. You divide by 2. And so now both of these equations must be true. You equate them. you move to the other side and you end up with x squared plus phi equals to 0, which clearly does not work. So this will be the point when you realize that you have understood the question wrongly, or at least you have misassumed something. I'm sure many of you had this experience and will have this experience in the SMO where you did something and then you get a contradiction, and then your first instinct is that, teacher, the question is wrong. It's happened before. It happened in last year's senior, it happened in last year's open. Thankfully, there was nothing wrong with this year's junior and senior. But do not assume the problem is with the question. I mean, it has happened before, but the problem is most likely you have misunderstood something or misassumed something. So in reality, B is going to be in the other direction. So it would be B is negative 2x, 2y. Sorry, I forgot. Negative 2x, negative 2y. It's on the other side, and you are substituting in, so it will look almost the same. So I don't really need to redo everything, because the only thing that changes after you simplify is just some signs. So you get y equals to negative 2x squared plus 5x plus 3. If this time you equate the two of them, x squared plus 5x minus 8 and negative 2x squared plus 5x plus 3, you're going to get so what 3? Sorry, my wrong, right? It's 4, right? It doesn't change the arguments that I had the whole time, but sorry if you were mystified for a second. I was just saying about calculation errors, right? And I made one of my own. So 3x squared is equal to 12, and x is positive because in the first quadrant, so x is 2. And then you substitute back in to find out that the value of y is 6. And just put it into any of these equations. Okay, so this is now the point at 2, 6, which was clearly not to scale. This is minus 4 minus 12. Although I don't really need to get AB, I just get OA, because OB is 2OA, means that AB is 3OA. So AB squared is 9OA squared, and by Pythagoras, OA squared is 2 squared plus 6 squared. So your answer is 360. This thing, question 23, which some of you have been discussing for a bit, is definitely not easy. This is a question that is on the harder side of the counting questions. It is on the harder side if you did not realize the harder side of it. What you may have just done almost by instinct is just, okay, there are 6 choices here, then there's 5 choices, 5 choices, 5 choices, 5 choices, and then the last one has 4 choices. That would give you 15,000. Is that right or wrong? Okay, so let's understand what has actually happened here, right? Now, if you did this, there are 6 choices for A, there are 5 choices for B, then there would be 5 choices for C, 5 for D, 5 for E, because they cannot repeat. But if A and E are the same, then there would be 5 choices for F. If A and E are different, then there are 4 choices for F. And so you cannot do multiplication like this if you have got cases. You cannot say multiply by sometimes 4, sometimes 5. What does that mean? But this attempt of trying to use a simple method is also a good way of helping us to know how to solve the question. Now, for those of you who are familiar with recurrences, I would encourage you to just verify that if we just let an be the number of ways for n regions, this is not the solution that I'm going to present, but for those of you who are familiar with recurrences, a1 is 6, a2 is 30, and an, you would be able to do something like not n, sorry, 6 times 5 to the n minus 1 minus an minus 1. This is actually the recurrence that would give you all the values. Now let me just show something that I think is more suitable for the SMO Junior, which is just split into cases, because we have just discovered the problem was to do with same color or different color. So I'm going to split into the cases of 2 opposite ones. So in other words, I'm trying to sort of break this loop up into 2 small bits. So case 1 would be A and D have the same color. Now if A and D have the same color, there are 6 choices for A and D. Let's say, for example, they all use color number 1. Now if I want to do B, I have got 5 choices, and whatever I use in B cannot be the same as D because it's not color number 1. So C will definitely have 4 choices. And the same thing would happen for E and F. So this would give me 6 times 20 times 20, which is 2,400. This is case 1. Now, case 2 is that A and D have different colors. Now, let's just call the colors 1 and 2. Right? Now, if A and D are different colors, then A and D this time have 6 times 5 choices first. Now the number of ways to do B and C is that for B and C, B is not 1, color number 1, and C is not color number 2. So I'll do them together. B has 5 choices. C also has 5 choices, but out of these 25 combinations, 4 of them are color 3, 4, 5, 6 for both. And the same thing will apply to E and F. Not equal, times one more time. So this is 6 times 5 times 21 times 21. Which is 13230, and that will give you your total. Yeah, so this kind of counting questions are not easy, definitely, but it does exist, sorry, there does exist a so-called elementary solution at least. Okay. Question 24. Now this rectangle is a little bit annoying in the sense that it's very easy to misread. But it's definitely not a very hard question. For the manyth time that we have said today, it is suitable as a primary school Olympiad question as well. If you really just think of it in terms of like the distance, speed, time of primary school law, it's just about them meeting. So it's when does this pair meet, when does that pair meet, and then that is good enough. Okay, so they start from these locations, A, C, and C. And this is going at 10, this is going at 8, this is going at 4. Now it's up to you to pick any pair, but I will just note where a pair of them meet. So for M and N, they start essentially half a loop apart. Half a loop is 30 meters. So the loop, one full loop is 60 meters. They start 30 meters apart with a 6 meter per minute differential, which means that you will catch after 5 minutes. 30 over 6, and then 60 over 6 is 10. So 10 minutes thereafter. Now for N and P, they start together, and there's a total of 12 meters per minute. So which means that they will cover a loop every 60 over 12, which is 5 minutes. Now this is enough, right? Because if M and N are in the same place, and N and P are in the same place, that just means they are all in the same place. So you just list, right? For M and N, every 5 minutes and every 10 minutes thereafter, all of these all fall into the meet every 5 minutes, and so the answer is just 45. I agree with the consensus that this question is not very hard. It is possible that by the time you reach here, your brain is just a bit dead, and the question is very long, and therefore you don't feel like doing it very much. For those of you who just took the SMO Junior, if you are doing a competition like this of 2.5 hours with actual difficulty involved in doing the questions, rather than, let's say, some of the competitions where you will just run out of time anyway and you don't need to do all the questions. Try to get used in your own time by some practice to thinking for the vast majority of 2.5 hours without stopping. It's not easy, and it does need some personal practice time to get used to it. Especially for senior, right? You will need all the time you can get for senior. For those of you who are in Sec 2 this year, join the senior stream tomorrow and you'll understand. Okay. And we are on to the last question, question 25, which gives me one last chance to lament / complain / moan about SMO diagrams. If you read the question carefully, so ABCD is a rectangle, a circle of radius 240 mm is inscribed in triangle ABD. BD is a common tangent to both the circle and the semicircle whose diameter CE lies on CD. It's given that CE is 720 mm. Find the perimeter of ABCD in mm. Forget the mm, I don't know why they want to use millimeters, but that's not the annoying part. The annoying part is that is this a point? the question did not say that the circle and the semicircle are tangent to each other. The question only said that the circle in the top left is inscribed in a triangle and the semicircle in the bottom right is inscribed in a triangle. It does not say that they are at the same place. I got a bit confused initially when trying to do that because I got a contradiction. And so very soon I realized that, well, yeah, the reason why I'm getting a contradiction is they didn't say that, and so these two actually are not meeting at the same point. So how are we going to do this question? The first thing that I'm going to mention is an area formula, which some of you know, which is area equals to R times S for a triangle. R is the in radius, which means the radius of the inscribed circle, like this circle here, and S is the semi-perimeter, which is just half of the perimeter. The reason for this is quite simple. If you have got any triangle and you drop the perpendiculars to all three sides, if I call this radius R, and you then chop up the triangle into three smaller triangles, you're going to get half times R times a side, half times R times another side, half times R times another side, which will total up to half times R times all three sides. So this is what I'm going to use here. So why am I using this? Well, I mean, you can see that the top left corner is a triangle with an in circle. For the one on the right, you see this is what I can do with technology. You can't move the SMO diagram, but I can. With the SMO diagram, you have enough space. So I'll just reflect it to create this. Now I'm going to call the sides of the rectangle A and B and the hypotenuse C. So using the area equals to RS, which is also half times base times height, right? That's not changed. ABD is that half AB equals to 240 times A plus B plus C over 2. Okay, so this is my equation number 1. AB is equal to 240 A plus B plus C. I'll do the same on my big triangle, which I call, let's call this point here F. There's no F, right? No F, okay. BDF. Now, the area of this is half times 2A times B. And for my in radius, it is 360 times 2A plus 2C over 2. So now it gives me AB is equal to 360A plus C. And this is nice because it immediately tells me how these two are the same. Tells me that A plus B plus C, if I simplify, 2A plus B plus C equals to 3A plus C, and so therefore 2B equals to A plus C, and that means B is the average of the two. Now of course you also have A squared plus B squared equals to C squared from Pythagoras, and so B is the average of A plus A and C, as well as A squared plus B squared is C squared, would just tell you that it's a 3, 4, 5 triangle. Of course you can verify this, but it is the only triangle where one of the sides is the average of the other two. It's also quite easy to infer that. So that allows me to get my A, B, and C. I'll just let my A be 3x, B be 4x, C be 5x, and then toss it into here. So x equals to 240, and the perimeter is 2a plus 2b, which is 14x is 3360. And that's the last question. I'm not joking when I say that right now at the end of this review, right, there is a high chance that many of you now do not even have the same opinion about the difficulty of the questions as you did 2 hours ago. I also probably do not have the same opinion of the difficulty as I did 2 hours ago. Your friends who are not watching this definitely have the same opinion they have about the difficulty of this as they did 2 hours ago. I still stand by the fact that this is a paper that looks pretty difficult, and so therefore it is favorable to those students among you who have had some Olympiad training, and the more preparation you have had, the more you will not get frightened by this. But it is a less approachable paper than has been the case in maybe the last few years. So for those of you who are a bit newer, please don't get discouraged. This is definitely more difficult looking, and by nature of Olympiads, they are meant to look hard, but the fact that they look hard makes them difficult, even though the solution may end up being fairly short for many of these problems. Alright, so I did not really get to answer a lot of your questions, also because I can't keep track of the chat or writing solutions entirely, so sorry if I did not answer some of you. All the best if you're taking the SMO Open tomorrow, and I will stick around here for a few more minutes to answer some of the questions in the chat, but otherwise for everyone else, thanks for watching. Do feel free to comment below on this video after the stream if you just think of something, and of course for those of you who are my students and are following, hope you did well as well. Okay, so I will go off camera for a bit, but I'll continue answering questions in the chat. Enjoy your holidays if you are done with the SMO for now. I cannot go off camera because everybody is just asking about the cutoff score, so I might as well just address it one last time, especially those of you that came in later. First of all, do not quote me, but my opinion is that it is possible, not guaranteed, and it never gets verified officially anyway. It's possible that because of the fact that it looks difficult, the cutoffs will go down. But I feel that the cutoffs may potentially affect the lower, like the easier questions are not so easy, meaning that it will not affect the difficulty of the score for gold. It will not affect the score for round 2 by more than 1 point, I feel, because round 2 we're talking about 100 people. I think for the top 100 students taking the SMO, if I'm being honest, I think that they will at least still be able to find the easy questions amidst the mess. Or for the really good ones, they might solve almost everything. So if I were to guess, I would say probably the round 2 cutoff, if it was 15, it will maybe just go down a point to 14. That is my best guess. But it is possible that the gap to the others can increase. So it's possible that, for example, the silver could go to an 11 instead of being 2 marks apart. Like it could be that the bronze goes as low as an 8. So the gap can become bigger potentially. That's what I can say is my sensing. But you must remember that they don't actually tell you what is the percentage cutoff for silver, bronze, or honorable mention as well. Over the years, they have changed their mind, and they do not officially publish it. So this is my guess. It is not entirely verified or verifiable, even in a few months' time. Now for gold, it cannot be possible for me to say without round 2, but all I can say is that usually cutoff plus 10 is enough, meaning that whatever the cutoff is, okay, maybe plus 10 is a little bit short, maybe something like cutoff plus like 12 to 13. So that would be looking at something like a 27-ish in a normal year. Now, one round 2 question that's easy changes everything. It can just lift the goal cutoff by 10. So high variance, but in terms of average, it would be something like that, which means that if your round 1 has something like 20 plus, you are not far from a goal. Right? That's what I can say. For those of you who are asking about the SMO junior team, the SMO junior team is solely based on round 2 only. It has nothing to do with round 1 as long as you qualified for round 2. So it's not based on total score. Okay, so yeah, I can put a copy of the question paper into the description after the stream is over. I need to put it in some Google Drive and share it everything, so I won't do it right now. Yeah, it has been uploaded on Reddit, that is true, so you can find it on Reddit. I guess the teacher side of me is just, please don't be discouraged, right? The math teachers are me. Please don't be discouraged by Olympiads. Olympiads are meant to be fun. Take it as a way of assessing your current familiarity with these concepts and not your overall intelligence. That's the teacher side of me. And the competitor side of me as a student last time is saying that the SMO has the right to ask anything they want. So we cannot really complain about anything because they have the right to ask any weird concepts and they did not promise anything. So that's from the competitor side, is that why are you complaining so much? The teacher side of me says that yes, it is very intimidating and it is discouraging. So probably there's a mix of those sentiments. Yeah, the cutoffs, what did I say? It's still on the screen. Right? So what's on the screen? This is my opinion. This is not verifiable, and as I said, it does change quite a lot in terms of the scores. What else do I want to say? Yeah, I'm supposed to do some advertising, right? So like and subscribe to the channel. And yes, I have classes. You can join my classes. But even if you're not joining my classes, do look at round 2 stuff in the meantime, right? What happens is that a lot of students get surprised because maybe this cutoff that I estimate is wrong. Maybe it turns out the cutoff is 12 because they want to have 200 people in round 2 instead of 100. And so then after you get a shock, then you look at round 2 questions and you're unprepared. So whether you join my classes or not, I would strongly suggest that you start looking at some round 2 questions just to get an idea of what's happening. And of course, if you are not confident of getting into round 2 but you are still interested in looking at those round 2 questions just to learn how they look like, you can. It is not a must. Again, whether it's in my class or not in my class, right? Wherever you're at, do consider it, because next year at this same time, whether you're doing senior if you are Sec 3 next year, or if you are doing junior as a Sec 2 next year, if you qualify for the round 2 and you have got 10 days to prepare for it, there's not enough time to get fully used to it. Okay, results will be released, the full results not so soon. So the round 2 name list will probably be released sometime in the middle of 2 weeks from now, right? So somewhere about 14 days time, give plus or minus 2 days. So it is probably going to be that the name list for round 2 is, when is that? 12th of June-ish. Usually middle of the 3rd week of the June holidays is like the mean, although there's quite a bit of variance. In terms of the full results, for gold, silver, bronze, that will usually come out in something like August-ish, as well as the top 30 name list being somewhere around August. July to August, depending, because there's also a lot of things like the SMO team, and then there's the top 10, which is not going to be revealed until the ceremony. So it depends on what exactly you're looking for. But round 2 name list is about 14 days from now. Full results for everything like gold, silver, bronze, honorable mention, probably in about a couple of months. Name list is released on the SMS website, at least for my students. I will certainly let you know if you have qualified, but I think your school teacher will also let you know if you have qualified. SMO team, yeah, so SMO team, the pathway is that if you get into the SMO team, the junior team through junior round 2, there is a selection test at the end of that series of lessons where you can get into the senior round 2, sorry, the senior team. The senior team can also be entered directly from senior round 2. But the national team, only through open round 2. So if you're a junior or senior team, it has no bearing on whether you get to open round 2. Get into the national team. The national team is only by open round 2, and then the national team is where they select the IMO team. That's the hierarchy and the sequencing of things. Junior team and senior team generally don't repeat as much. For national team, you can be there for many years. I don't want to do too much advertising, right? I mean, generally there's a welcome, but I don't want to do too much advertising. So I will put the link to my lessons in the description below, but please do not take it as any obligation at all. Right? If you, there's also my contact below. So if you want to just contact me, I have put my email, I've put my Telegram. That should be enough for you to reach me if you need to. Yeah, so you can use that contact if there's anything else. Otherwise, I think I'll wrap this session first. And yeah, once more, thanks for being here. And if you're joining you're taking the SMO Open tomorrow, then all the best.